maths and physics. These are two really closely related sciences. As such, it is very natural to ask oneself whether any of these sciences come before the other one. Is it true that physics would not exist without math, or perhaps is it the other way around? Or is it none of that? So I will try to address this question during my 5-minute talk, starting out by physics. So, physics is a science that's developed so much in the last 2 centuries thanks to math. Math has brought so many tools for physicians to handle numbers and analytical questions with much ease and with way more trust in the rigorous definitions behind them. So um, I think it's undisputable that physics would not be the same without math. So, of course, physics is a quantitative science and it studies completely different objects to what math does study. And it's a completely different science in some sense. I mean, physics studies the material world, and many physicians will tell you, just as Einstein himself said, that physics is more of a conceptual science, and you can perfectly do physics in English or in Latin or in French or in any other language, just as physicians have done since the very first ancient Greeks scientists up until the Middle Ages, where math started to develop, as we've seen in class. So that is completely true. That it's completely true that physics would not be the same without math. But on the other hand, one may be tempted to think that perhaps math is this sort of universal, pure sun that sheds light on every other discipline and that illuminates everything by standing on its own without the help of any other applied science. And while it's true that math is almost ubiquitous, I mean, in the scientific disciplines, I mean, you won't see any scientific article without some sort of numbers or at least some metric in it. Math is completely useful to every other science, and in some sense, formally, you don't need any science in order to have math. So, if you go to the foundation of math, you start to read books on set theory, on logic. You will see that indeed there's no mention to the object of our world. There's no need to know about physics or chemistry or biology or medicine or anything like that in order to have math. But that does not mean that math doesn't need these sciences. Why? Because by saying that, you're assuming that math is purely formal, and that is a complete mistake in my opinion. So math is way more than formal. Many objects in math have been studied long before they could be formally defined. The reason they were studied so early is because there was a physical intuition telling you that, well, it might be super helpful to study this object, which seems to have so many important properties. So think of the real numbers. The real numbers are a little painstaking to define. I mean, you have to know about complete spaces, and it's not at all trivial to define them. And yet they were studied ever since Euclid studied them when he was talking about lines and intersecting lines. He was using a real valued space, which is not at all trivial to define. Why, you may ask? Well, because our world is real. Our world is it's R3, right? We live in R3. And there's no way to not look at that. It's so natural for us mathematicians to study R, because R is the world we're living in. And the real numbers are one of the most central objects in mathematics, used in algebra, analysis, and so many areas. So, of course, you would not study those numbers if it weren't for the physical intuition that comes with them, if it weren't for physics. I could keep on talking about these things. I mean, you have, especially, I think, the most recent proof that physics is so necessary to math is the development of the differential equations and the PDE theories. So, on one hand, you have physicists which use math as this super consistent language that serves as a tool to develop quantitative theories with good rigor and good consistency. And at the same time, you have math, which is this super pure discipline, which nevertheless has a big lantern in front of it, which is physics, and tells it which way to head in each moment. Of course, physics won't tell you like the key steps to take, or at least like the way to go, or in more simple terms, it won't tell you the proofs of your theorems oftentimes, but it will tell you which theorems to prove and which way to go. So I hope to have convinced you of my vision of this interplay, and I hope to see your videos very soon. Thank you.